Blistering speed is R C++ really so scary? Now, this is stated as a question, so Luke, my answer isn't necessarily no. It might still be scary, but it might still be useful. Okay, so C what am I talking about here? So C++ is what some kind of general purpose, multi-paradigm, strongly typed compiled language. What? See what is this thing? For my interests, all I care about is that C++ can be really fast. We don't care about most of that stuff really. I'm going to use it as a really fast calculator. So really it's a lower level language than R. It can go really fast. And if we kind of ignore a lot of that complicated stuff like object-oriented things, which might be useful, but for my purposes, I don't really care. If we ignore that stuff, we can actually get on to doing kind of simple tasks relatively quickly. That is, I mean, in development time, you can get onto making things fast in kind of running time. Okay. And what's interesting is that, loads of R just under the hood is actually C and C++ and Fortran and all these low-level languages. So if you kind of go into some kind of deploy function and dig down into what's going on, you might get to some kind of C++ function that it actually calls at some point. So this is in the filter function at the end. No idea what this really does, but it calls some C++ function. Looks like this. Who cares? Does some complicated stuff. Basically, this is going on under the hood all the time, and you don't really know about it. But we can use it to our advantage. So the R package um, has been around for a while now, and I think it's in a good, like at least 1,000 packages. Use this to some degree. And basically what it does is lets us call C++ code from R. And you can do this other ways or kind of really old school ways to do this. I mean, the way base R is calling on C functions and Fortran functions, they're not using this RC++ package, they're doing something else. But the RC++ package makes most of this way easier, takes out a lot of the headaches. And also it adds some kind of functionality where you can kind of still vectorize your code and call in some kind of other R code and things, and it's pretty neat. So just a little bit about me very quickly. I'm a PhD student in mathematics at Queen's in Belfast. And basically, my PhD has been about doing kind of survival analysis with so-called interval censored data. So this is when you don't know exactly when something happened, just kind of happened between two events. I'm looking at all this kind of non-parametric maximum likelihood stuff. And the important thing is I need to do lots of iterative algorithms and I want them to be fast. I need to do bootstraps and things like that. So I'm going to just be running things lots of times. And I don't want to be sitting around all day waiting for stuff. Um, so, okay, if we're using RC++, how fast are we talking? Well, pretty fast. So this is just some example I stole from the Efficient R programming book. Someone's written some function in pure R and then kind of compared different methods of kind of byte compiled R and then a version in RC++. It's got a little sneaky one in base here, but really what that's doing is the base version is actually also calling C++ or C probably. So that's why they're kind of the same speed. But, that's probably for a very simple function like sum or mean or something like that. But we want to do kind of more complicated things than that, right? So I'm just going to give us a small example from my work to show the kind of difference in speed. Sorry, I think someone has drawn on my screen. I don't think that was me, but anyway, please ignore this big yellow line. Anyway, so this is some stuff that I've written. It's just I'm simulating some data and then doing this kind of non-parametric maximum likelihood stuff on it. Doesn't matter about the details, but I've implemented it twice. Basically, I implemented it all in R, and then I thought, okay, how much faster can we make this? So this first method here, we're going to do it in R. So this is just running through some stuff. It's just telling me something about the iterations here. This next one basically does some stuff in R, then shoots everything off to C++, does all the kind of iterative stuff there, and then shoots back out to R at the end. So there is, I mean, this isn't pure C code that I'm calling, but anyway, there's some R in there. Let's just see what happens. Run that. Okay, it prints out more stuff that I should have taken out when debugging it, but anyway, it was a bit faster. So my crude way of measuring times in those functions, so the R function took 2.5 seconds. My C++ version took 0.05 seconds. So it's a difference, a speed up of 40 plus times. Okay, cool. That's really nice if you're running stuff over and over again. But yeah, my kind of small caveat when it comes to speeding things up in your code, um, most of the time I feel like don't waste your time speeding stuff up unless you really need to. So my best solution is usually be patient. Find out whether or not you really need to speed up this bit of code. Just throw it at a faster computer if you can. That's what Olivia was talking about earlier. She's kind of throwing stuff off to some fast kind of supercomputer somewhere, and that's probably a lot easier than re-implementing everything. And try to find out if someone solved this same problem because ultimately there's some trade-off between the amount of time you spend learning C++ plus plus and all this jazz compared to how often you're going to run something and how much of a difference that makes. This is some kind of old XKCD comic that's kind of outlining how much time you actually have to save from something compared to how often you do it, right? Um, if you only save 1 second and you do something 50 times a day, then don't spend longer than 1 day uh, doing it. Okay, so C++, plus plus. What do we really care about here? The most important things, oh, I should probably be presenting this properly, so I don't look like an idiot. The most important things are that we have to declare variables before we use them. So in R, when we make a vector called x, R just deals with that, right? We just say x is blah, blah, blah. In C++, we're going to have to say, okay, this is a vector full of doubles or integers or Boolean things. Um, all these different types. You kind of have to declare them explicitly. The thing that would definitely trip you up, and has tripped me up 1,000 times, is that loops start at 0. So if you're doing a for loop, the first element of your vector or whatever will be 0, element number 0. Um, yeah, if you're translating between code, you're going to follow all over that all the time. I think that's just part of the course. It's just you have to deal with that. And by default, C++ doesn't kind of have all this kind of simple vectorization in it and stuff. There are libraries that allow you to do that, but most of the time, what you're going to be doing is probably loads of for loops. And I think for loops have a bit of a bad reputation in R, but in C++, there's very little overhead to them, and you can just zip through things really quickly with for loops. Okay, let's give you a very kind of quick example of something here. Here we go. This is a very kind of naive sum function, right? That I've made in R. Actually, I stole this off of Hadley's advanced R book, but um, let's say that I did it. This is just sum R. I make sum total, and then I go through some sequence. I'm going to sum up this vector x. I go through and I keep adding stuff to my total, and I return my total. Okay? And then we're going to do an example in C++. So this is the really kind of basic thing that every one of these R C++ tutorials tells you to do and starts with is this kind of really simple method where you just write C++ code and kind of paste it in as a string, right? So we can kind of see what's going on here. Like I said, in C++, we have to say what type of variable we have. So this is saying double. Double is just like, think about that as like some real number, right? If my function returns a real number, this is the name of my function. This basically tells it what it's expecting in as an argument. A numeric vector, that's kind of what it expects from R. And a lot of C++ is kind of getting used to and memorizing some of these different data types, and this one in particular is specific to R C++. But anyway, and then we go through here, we make some integer n, which is the size of our numeric vector. So we're just going to say how long it is. Notice that we've not used like a size. This kind of size function is kind of part of the numeric vector. That's kind of to do with the kind of object-oriented side of C++, but we don't really care about that too much. So this is going to tell us how long our vector is. This double total, we're going to say, once again, we're going to return some value that's a real number, and we're going to call it total. And then we go through this process of making a for loop and zipping through everything. And the for loop, you'll notice, is slightly more complicated than in R. So we have to say that, first of all, our I that we're using to kind of iterate things is an integer, and we're saying how big the integer is going to get. It's going to get no bigger than n. Oh yeah, notice again here that we start our loop at 0, and then this thing at the end is just saying we're adding 1 to I at every step. okay, I don't want to teach you all the things about C++, but that's kind of a rough outline of it. And at every step, we're going to add the current value in our vector to our total, right? We're just zipping through this and adding every value in our vector to our total and returning that total. Okay. And the thing about C++ is it needs to be compiled. So if I was to run this, so I can very quickly just source my R function. If I do this for the C++ one, you'll notice that it takes a little bit longer. This isn't me running the function, it's just me kind of compiling it and loading it into my environment. So that was pretty quick, okay. Um, and then if we just go through an example here, is this going to work? It should do. Right, I've just run this 1,000 times or something. And so the sum here is my naive attempt at the top. My sum C1 is, oh, sorry, no, excuse me. Sorry. Sum is the inbuilt one, which is already like super kind of, what's the word, optimized to be really fast. Sum C is the C version that I've just made here, right? 4 was at microseconds, and sum R is the version I've made up here in R, right? That 19 microseconds. So the sum R one definitely takes longer than the sum C one. And sum, once again, that's an inbuilt one that's really optimized, right? But we kind of, for anything more complicated than something like sum, there's no easy, already optimized alternative for us. Okay, so that's a very quick example. But we probably, if when things get more complicated, we don't want to just be like pasting strings of C++ around. So we're going to probably want to put things into their own script. And here there's a little bit more overhead where we have to tell R++ that we export this as a function and kind of add some extra things that kind of tell us about libraries and all that kind of jazz. But then we do kind of an extra step. We can source Rcpp, and that's just going to kind of load up something from a script. So this is a little bit nicer, right? Because you can just go into some kind of IDE. Actually, if you load C++ code into RStudio, it's kind of good at highlighting if you've made a mistake with some syntax or whatever. If I delete that, let's see what that does. I should come up with an extra thing that says, oh yeah, that's another thing about C++. It wants little semicolons at the end of lines. That'll trip you up as well. But anyway, um, it's kind of good at picking up on things, but RStudio is not great at all this other stuff about dealing with the fact that we're using a different package and all this jazz. So it kind of comes up with extra problems that we don't really want to face. But anyway, it will still work. So if I do this, it'll take a little second to kind of compile that behind the scenes and get it ready. But that's just doing the exact same thing as this. But it just allows you to deal with slightly more complicated functions. Okay, let's get back to here. Okay, that was a really kind of simple example. We had our pasting things in and compiling them with our C++ function. And then we had a version where we put everything into a script and dealt with that. But they're kind of stupid examples, really, right? You're not going to be doing this. Like I said, really, you should be waiting for as long as possible before you do your RC++ stuff. So there's kind of some phase in the middle here that gets slightly complicated. This is where it does get scary, maybe, where you have to set up all your kind of compiler and things and all this jazz to deal with C++ properly so you can really debug it. But you can do this in the afternoon. I've left you with some resources here at the end that kind of set you up with all of this. And I would basically recommend that you use something like Visual Studio Code because you can run both R and C++ from within there. And there's kind of, there's some things that you need, but honestly, you can get through this with some patience within an afternoon, maybe a day. And once you're set up, this is ridiculously powerful, really. So I'm going to very quickly do this because I know I'm running out of time. One last example. So here is basically some package that I've created where once again, I've got a load of C++ code. But in this example, I've got everything in its nice little script here. This is just a C++ script. And I've set everything up as a package. And once you kind of set everything up correctly like this, then you can really nicely debug things. So I have a little R code that calls on this C++ function, wherever it is. It's probably inside here somewhere. And then I can properly debug things. And the way Visual Studio Code does this is you kind of set up one script and we're going to say, hey, let's debug this script, and it'll run it through. And if I just click on here, obviously with some amount of setup behind the scenes here that's happened, and I have basically a full debugger, and this is really powerful, right? So I can put in little stop points, and I can put these wherever I want. You can do this within RStudio, by the way, with R, which I would recommend everyone should do, even if you never touch R C++. You should get used to the debugger in R, which isn't just using the browser function. You can kind of add stop points in and stuff. And I can jump through here, right? So I can continue through here. And I've got something here that lets me kind of watch these watching variables basically means I can see what value they currently are, right? It'll tell me how big they are. This is what all the values are currently in it. And I can step through here one piece at a time. Um, and yeah, this does involve some amount of work to get your setup like this. But once you do this, you can really kind of powerfully interact with C++ and call things uh, from R really nicely. Okay, so I know this isn't in very much detail, but I don't want to bore you with details because if I went through the details, you'd probably never do it. And honestly, once you get started, you know, it's okay to do. It's just a bit fiddly. So my recommendations with C++ and R C++ is really to do as little as possible within C++. Do all kind of your pre-processing within R, and if you have one big kind of iterative algorithm or something, put that into C++ and actually find the bits that are kind of the most repetitive and are actually slowing you down. So just earlier, I think Harriet mentioned the micro benchmark package. That's really good. If you're ever thinking about doing this, make sure you know which bit's slowing you down because there's obviously kind of a huge setup cost to dealing with all of this C++ stuff. Make sure that it's actually worth your time to do it and make sure it's something you're going to be repeating loads. Um, yeah, okay. That was a whistle-stop tour of RC++. Thank you for listening.
Great stuff. Thanks a
Hopefully
lot,
that's some.
Zach. Really interesting, and I, for one, will be doing as little as possible in C++. Um, so Howard has dropped a comment in just showing the implementation of R Markov loop written using Rcpp with
Okay.
some called CP code. There's a question from, I think, yeah, if I'm saying that right, could ChatGPT be a useful tool in helping to code in C++?
Yes, absolutely. Yeah, yeah. So actually, that's another kind of cool thing about Visual Studio Code. I think you can do this within RStudio, but I've never actually done it. But if I find somewhere down here, I have my little Copilot guy. It's got pretty good Copilot kind of, what's the word? Um, implementation. So I'm sure I can chat with him and stuff. Let's see. What will he do? Oh yeah, I can. Yeah, so basically you can bring up Copilot within Visual Studio Code, and it also starts doing like let's see, it kind of starts suggesting things really nicely. Like it starts suggesting code completions and stuff. That's a little bit kind of one step further than just inbuilt stuff. And actually, I find that really useful for documenting things. Actually, you'll notice that I haven't actually documented any of this. Let's see, it'll probably tell me how to um, complete some of these. There you go. Parameter for left interval times. That's actually pretty correct for this example. So it's really good for stuff like that. If you start talking to it and asking it how to implement a specific thing in C++, it will probably be pretty helpful. But yeah, so long as you set up a debugger so you can actually check that ChatGPT is talking sense to you, then I think that's probably a pretty smart way to go.
And just as a maybe a final question with an eye on time, where would you think in HTA are the killer applications for C++? So one area I've encountered it recently is when a collaborator used this to do the difficult bit of a very large and complex microsimulation cancer
Yeah.
screening model. So going back to Olivia's was for a different cancer, and that was a huge efficiency gain. Are there other ones that might be less obvious to someone like me who's really only touched this at the very fringes and is unlikely to be programming it directly?
I would say probably, yeah. I mean, the micro simulation, I think, is probably the one that kind of screams to me most obviously. I guess the Javier the other day was talking about the Warden package and maybe implementing parts of that. I guess it's, probably pretty good if you have a package that you know lots of other people use, which, I know isn't everyone here, but that's probably a really good example as well, where you know the things that are slowing you and other people down. But I imagine that's probably also a case where you need to start using the fancier, more complicated parts of C++ to kind of really get the most out of that. But yeah, I would say probably pretty much anything that is really repetitive. I guess if you were doing, a huge kind of sensitivity analysis where you're just running things thousands and thousands of times, then you'd probably pretty quickly find somewhere that you could speed it up. Um, but yeah,
Fantastic. That's great. And there's a few more comments and GitHub links being
yeah,
dropped into the chat.
cool.
So wonderful. Thank you, Zach.
Cool. Cheers.